Okay, we're back again. This should be for Monday's lecture, April 27th. It's part 2 of fractions. So I have posted just page numbers and problem numbers for your assignment on the second part of fractions on Blackboard. I know it's kind of hard. Generally I just have people either take pictures of their homework in the classroom, or they just hand in the pieces of paper, obviously from like their notebooks and that. But it helps out if you can make sure that all of your homework assignments obviously have the correct page numbers and the problem numbers. So that definitely helps me out so that I can make sure that I'm grading everything. I can follow it, otherwise it makes it a nightmare. And then I'm going to go ahead and post for you to look at Monday to kind of see how you can download or upload or whatever your assignments to Blackboard, and I'll have it in that format. So I'm making this lecture now today, Friday, in the afternoon after we talked this morning. So I want to spend a little bit of time looking at that, and I'll get that so that when we go forward to decimals, you have that capability to upload your assignments that way, and then that's kind of nice too, because it just kind of keeps track of it a little bit better for me on this side. And now that you have your textbook, hopefully this is making it easier for you also. I'm going to make page references throughout this lecture to kind of help you to refer to. Before I forget to let you know also, all of the odd number problems the answers are in the back of the book. So that's why I assign the even numbers for the most part. So if you want to make sure that you're doing it right, you're not quite sure, double check with those odd number answers, because chances are the same type of problem is being done in each of those practice sets. So alright, so we're moving on with part 2 of fractions. Just kind of, I should change my slide. So just kind of looking at some of the different math sense of looking at, when we look at fractions, that any number over itself always equals 1. Okay, so in the examples there that are shown, any number over itself is equal to 1. Okay, and then any numerator that has 1 as its denominator should just be the same as just the whole number. So as you can see, 4 over 1 is 4, it's the same as 4, 51 over 1 is the same as 51, and so on. Okay, and then you can actually change every whole number into a fraction by just putting a 1 under the denominator, but it doesn't change the value of the number. Okay, so that's just some kind of math sense there as we move forward. Alright, so finding the common denominator. So again, as we mentioned in the previous, so this is kind of overlapping a little bit, but it's just another PowerPoint. You want to make sure that you find the common denominator when you're adding and subtracting numbers, or fractions, I'm sorry. And the lowest common denominator is the smallest number or multiple that both of the denominators of the fractions can go into. Okay, so they talk more about this as your reference page is going to be page 39 in your textbook. Okay, so as we look at the common denominators, and I'm going to go ahead and I'll probably have to write on the screen. I forgot to insert a blank, darn it. Anyway, so we're looking at this, and this was a common one I think that we looked at the first time. So we're looking at adding 2/3 plus 1/6. Okay, so we look at our denominators, which are 3 and 6, and we have to look at what is something that can go into both of these numbers. Okay, so 3 obviously can go into 6 2 times. Okay, so 6 is going to be our common denominator. So we need to So 6 goes into itself once, so that is left alone, okay? And then 3 goes into 6 2 times. So then we're going to change our 2/3. So we're going to take our 2 over, I hate this thing, our 2 over 3, okay? And we're going to times it by 2. Both the top and the bottom are going to be times by 2, okay? So that is going to give us then 4/6. Okay, so we've got 3 times 2 on the bottom, 2 times 2 on the top. So then we can go ahead and we can add this. Then we can go ahead and add our 1/6, okay? And that should give us 5/6 as the answer. So we need to make sure that we're able to find the common denominator. Okay, so looking at, okay, so I made a mistake there. I accidentally erased the wrong thing. So we had the 3 over the 13, which ended up being 12 over 52, and then I have to go ahead and take the 1/4. I tried to use something different on my mouse and it made a mistake. I'm going to go ahead and take that now and multiply both the top and the bottom by 13. Okay, so that's going to basically turn this fraction into 13 over 52. Okay, so I multiplied them both by 13. Okay, I took the 1 by 13. I'm not going to write that out again. And then I took the 4 by 13. That gave me the 52. So I have, what did I have? 12, I believe, over 52 plus 13 over 52. So then I would add those together. So that would give me 25 over 52. So that should hopefully be right. Yes. All right. And again, this is on page 39 in your book. All right. Oh, yeah. So here we go. Kind of, I should just went to the next slide, even though I already had looked at this. Yes, so we have the 12 over 52 and then the 13 over 52, right? Okay, so what about order of fractions? Okay, how do we look at that? So we have an example here of 1/4 over, or 3/8. So which one is bigger? Okay, so again we have to find the common denominator. So our common denominator there is 8. In order to get the 4 to the 8, we had to multiply it by 2. Okay, so then we had to do the same to the top. So we turned the 1/4 into 2/8. Okay, so then that makes it easier to see which one is bigger. All right, so your 3/8 is obviously more than your 2/8. So then if we convert it back to our original problem, the 3/8 is going to be greater than the 1/4. Okay, so make sure you write it back into the original form. I have another problem here, and I'm going to write down the fractions up here. So this is from page 51. So we have 1/4, 2/9, and the other one is 4 over 12. And if we were to put these in the proper order, which is the biggest fraction, we need to find the common denominator. Okay, so we're looking at 4, 9, and 12. So think about what number, those numbers can't go into 12, okay? But I know that 9 times 4 is 36, and 12 can go into 36. So we're going to make 36 our common denominator, all right? So we're going to turn the 1/4, and I would love it if you guys are working on this kind of with me. So we're going to take that 1/4, okay, and we are going to turn that into 36 being the common denominator. Well, how did I get 36 from the 4? I had to multiply that by 9. Okay, so 9 times 4 is 36. So I have to take the top and multiply it by 9. So that turns the 1/4 then into 9 over 36. Okay, now I have to do the same thing with the 2/9. So I have 2 over 9. Beat this thing yet. Okay, again, I'm making 36 my common denominator. So what did I do to the 9 to turn it into 36? I had to multiply it by 4. This is 9. So I have to multiply this by 4. And that's going to make this 8 over 36. And then lastly, I have, so I've done the 1/4, I've done the 2/9, and now I have to look at my 4 over 12. Put that over here. And I gotta turn my 12 into 36, so I multiply it by 3. Okay, I multiplied this by 3, so I have to multiply this by 3. So I got 12 over 36. So now all these numbers have a common denominator. So I'm able to compare these numbers much better with a common denominator. So which one is the biggest one? Our biggest one then is 4/12. So this will be our largest. Okay, so this would be like number 1. Okay, then this would be our second one, 9 over 36. And then lastly, 2 over 9. Okay, so this would be the largest here. Little star, and then this one, check mark. And then lastly that one. Okay, thanks for your patience there. All right, moving on. So a lot of these subjects we've kind of talked about, but we're just kind of hitting it again. So now we're looking at borrowing again when subtracting fractions. Okay, so it's just written just a little bit differently. So we're looking at 17 3/8 minus 14 4/8. Well, we know that we cannot take 4 away from 3 when we look at that fraction, right? So this is on page 52 and 53 in your textbook. So we're going to go ahead then and change that 17 3/8. We are going to borrow 1. We're going to take a whole 1 away from that 17. So our 17 is going to turn into a 16. Okay, and remember 8 over 8 is equal to 1. So there's our 1 that we took away. Okay, and then we still have our 3/8. So then we have to add the numerator. So we're adding the 3 plus the 8, which gives us 11 over 8. And then we're down to 16 because we borrowed. Okay, so now we have turned that into 17 3/8 is the same as 16 over 11/8 right here. Now we're able to go ahead and subtract that 14 4/8. So we'll look at taking this 14 away from the 16. That gives us 2. And now we can take 4, this 4 here, away from the 11. I hope my little cursor, I'm not sure if that's working or not. We'll take the 4 away from the 11 then, and that'll give us 7/8. Okay, so that was in page 54 in your textbook also. So let me just double check this. Yes, 54 in your textbook has the whole problem kind of written out, but the borrowing of subtraction starts on about 52 and 53. Sorry you have to rely so much on your book, but fortunately it's out of my control right now. Alright, so we have another example here of borrowing from a fraction. So we start with 11 minus 5 over 6, or 5/6. Okay, so we're going to we could look at 11 and 11 just being over 1, but we're going to need to make a fraction out of that. So the 11 over 1 isn't going to work, okay? So what we need to do is we need to make a fraction from this number 11. So if we borrow 1 away from 11, that turns into 10, okay? And then 6 then is equal to 1, so 10 plus the 1 is 11 again. So now we have 10 over 6 minus 5 6, okay? So we're going to go ahead and take 10 minus, we don't have anything, a whole number to subtract from, so we leave it at 10, but we can take our 6 minus our 5, which equals 1/6, okay? So that's just dealing with mixed numbers. I was actually looking at this problem in a different way, so just bear with me while I try to write this out here. So I was just talking about how we could change the 11 into a fraction. So we would do that by taking the 11, okay, putting it under 1, okay, minus 5 6. Sometimes this works, sometimes it doesn't. Okay, but we can't subtract like that. Like, okay, so you see how the one way we did it, how we changed the number 11 to 10 and 6 6, right? But there's another way we could do it. We could take and make a common denominator. Okay, so we could change that 11 over 1. There's just a different way of doing it. That's the fun part about math, I think, is sometimes there's more than one way to skin a cat. Not that I have anything against cats, it's just a saying. So in order to get the 1 to the 6, I'm going to make my common denominator 6. Okay, I'm going to change this to 6. I had to take the 1 times the 6, and this is going to turn into then 66. Because I have 11 minus the 66. I mean 11 times the 6. Sorry. Now I have a common denominator. So now I've got my 5 6 again. Okay. If I do my math, I take 5 away from 66. I should have 61 over 6. So that's an improper fraction because the top is heavier. So if I reduce this and put it to a mixed number, I should get the same as this. Okay, and I do. 6 goes into 61 10 times. Okay, because 10 times 6 is 60. And then I have 1 left over. There's your 1/6. Kind of cool, huh? All right, so that should be a 6. Okay, moving on to the next slide. All right, so complex fractions. So we're looking at complex fractions. We're going to kind of take samples right out of the textbook, and one of the other times I taught this, I just took pictures right out of the book. So we're actually looking at a fraction. A complex fraction is a fraction within a fraction. Okay, so for example, how would you take a quarter, 1/4 of something, and you would divide it by 10? Okay, so in our actual problem, you're going to, the whole number is going to again require that you place a 1 as its denominator. Okay, and this time we're going to be working with division or multiplication. All right, so move on to the next page here. So this is an example of taking 1/4 and dividing it by 6. Okay, so we're just looking at the top part of this, the 1/4 divided by 6. Okay, so if we look down here, 1/4 divided by 6. Okay, this is where you have to put a 1 underneath it. Okay, because now we're talking about division. But if you remember in division, we are going to then, so this is turned into 6 over 1, but in division we're going to flip it. Okay, so now we have 1/4 times 1/6. Okay, so we flip it and then we multiply. So then that gives us 1/24. Okay, so if we were to take 1/4 of something and divide, let's say 1/4 of like a piece of pie, and then you would divide it into 6 more pieces, 6 individual teeny tiny slices, it would be down to 1/24. Okay, and 1/24 is definitely smaller than 1/4. All right, so in this one here, we're looking at 3/4 divided by 1/100th. Okay, so again, this one here, we take 3/4 divided by 1/100. We change it into a multiplication problem. So we're going to flip this one here. Okay, and so it's the second one. So basically the smaller number. And you're going to flip that, and then you're going to multiply straight across 300 over 4, which actually reduces down to 75 over 1, or 75. Okay, so this again is on page 71 in your text. All right. So we use fractions pretty much every day. We talk about a half of an hour, or 7.5 minutes, or 4.5 hours. We also use them in measurements when we're talking about cups, 1.5 cups, or a half of a teaspoon, or weights or pounds. So one of the things that you need to do is you have to convert things into the same unit. Okay, so we're going to just start off with some of the more common units that we are more used to working with, and as we go on here, we'll be switching into more metric stuff. So for example, here in this one, you have a doctor wants a patient to drink 1.5 quarts of a medical preparation before a CT scan. They use a cup to measure the liquid. There's a little typo there. So as one of your conversions, on page 73 you have some conversions here, and I know for a lot of you, you probably don't know a lot of this off your top of your head. I was always kind of fortunate that I grew up in the country where 4-H was a big part of when I was a kid, and my mom did a lot of baking and cooking and stuff, so I have a lot of these numbers just kind of in my head just from that. But if we're looking at how do we convert this, okay, we're going to do quarts to cups. Okay, so we can kind of just basically what we have to figure out an equivalent ratio. Okay, so kind of like an equivalent fraction, but an equivalent ratio. So we're looking at 1 cup, or 1 quart rather. So we have 1 quart is the same as 4 cups. Okay, so this is kind of like looking at ratios, and we'll be looking at ratios too the next couple weeks. So this is kind of the same as 1 quart is equal to 4 cups. Okay, I'm not going to bother with the S. Okay, so we want to know then how many cups are in 1.5 quarts. Okay, so there's a couple different ways of doing it. I'm going to go ahead and stick with the fraction format just because that's what we're using right now. So 1.5, okay, is also equal to 3 over 2. Okay, you take 2 times the 1 plus the 1 is 3 over 2. Okay, so you're trying to solve for x. Here's your x here. Okay, so we're trying to figure out how many cups. Right, so in this particular problem then, we're going to just kind of cross multiply. We're going to multiply 4 cups by the 3 over 2. Okay, and then we would divide just by 1, because that's our number over here is 1. So they went ahead and here's the 3 over 2. Okay, and then the 4 over 1, okay, because you could just put 4 over 1. So you multiply then straight across. So you have your 3 times your 4, which equals 12, and then your 2 times your 1 equals 2. So then you end up with 12 over 2, which then is 6 cups. Okay, some of you may not even have to do that. You could figure it out in your head. You think, okay, well, 1 quart. So always tell yourself, does it make sense? Okay, so you know you're going to have more cups with 1.5 quarts, right? Because you have another extra half of a quart. So another, I mean, just kind of math sense. You look at 1 quart, there's 4 cups, so I'm going to add another half of a quart to that. So half of 4 is 2, so 4 plus 2 is 6. Okay, I mean, some of them are really quite that easy, but other ones you have to do the actual long drawn out math, and this is kind of the way of doing it. I kind of tend to make things a little more difficult. I don't like to skip steps. I mean, I will sometimes, but I know from teaching this in previous classes, I'll have a lot of students that'll come up to the board and they'll kind of do shortcuts, and that's fine. Whatever works for you, okay? Whatever makes sense, whatever clicks for you. I can't emphasize that enough, and that's what I really like about teaching math in the classroom, is that you all get a chance to come up and share your ideas and help each other out, because my way of doing it isn't the only way of doing it. There's several different ways of doing it, and whatever one makes the most sense. So this is again out of your textbook. On page 73 here, it's showing you those conversions. You know, this is one way of kind of looking at it, how you multiply things. I have just kind of a different way. I guess I've got some of these sort of memorized in my head. You know, 4 quarts, they call it a quart because it's a quarter of a gallon. Okay, there's always 4 quarts to a gallon, and then a quart has 2 pints in it, because a quart is 32 ounces and a pint is 16 ounces. So you'll have to kind of play with these numbers. There are going to be a lot of problems like this, but you should be able to understand how to work back and forth between them. Alright, and so the last concept really for today then is just understanding what the term reciprocal means, okay? Because I do know there is definitely a test question. What is the reciprocal? And the reciprocal is just basically the flip-flop, okay, of that number, okay? So you just flip it around, okay? And probably the one that people get tripped up on the most is the whole number, okay? So that last example there, what is the reciprocal of 4, or 4 over 1? Because remember, 4 over 1 is the same as 4. So you just flip it. The reciprocal then is 1/4, okay? Make sure you get that down, because I know for sure that's a test question, mainly with the whole number. With the fractions there, the reciprocal of that fraction is just flipping the number the other way. Okay? Alright, so get that terminology down. Let me see, that is on a page reference now that I think about it. There is a lot of information in chapter 2. So that's why I kind of broke it down into 2 lectures. Page 65 is what defines reciprocal. So make sure you've got plenty of extra problems here, and you've got a lot of homework problems to work on. So if you're not really sure on the concept of it, you can email me, or you can, always take a look at your odd number problems and double check the answers in the back and see if if you're doing it correctly. All right, we'll see you next time.